It is not acceptable to pack all the small ground or neutral connecting spots to free up a large one. Doing so may compromise the safety and reliability of the electrical system. Instead, you should install a new neutral bus into the main distribution panel to provide additional space for the sub-pole connections. Yes, it is acceptable to add an additional neutral bus in the main distribution panel if there is insufficient space on the existing buses. Firstly, purchase a neutral bus that is compatible with the main distribution panel. Secondly, shut off the main power to the panel. Thirdly, remove the cover and identify an empty mounting location for the additional bus. Fourthly, install the new bus using the provided hardware and torque the connections as specified. Fifthly, connect the neutral conductors from the sub-pole and any other circuits that require a neutral to the new bus. Sixthly, reinstall the cover and turn on the main power. Make sure the new neutral bus is properly bonded to the grounding system of the panel. Ensure there is adequate space in the panel to accommodate the additional conductors and bus. If you are not comfortable performing electrical work, it is recommended to hire a qualified electrician to install the new neutral bus. A neutral bus is a crucial component in an electrical panel, serving as a common point for neutral conductors to connect and return current to the source. When the existing neutral bus in a main distribution panel becomes overcrowded, adding an additional neutral bus can be a practical solution to maintain safety and functionality. Here is a more detailed explanation of the process and considerations. First step is to select a compatible neutral bus. Ensure that the new neutral bus is designed for use with your specific main distribution panel. Check the panel's specifications and documentation to determine the appropriate type and size of neutral bus. Consider the number of terminations needed on the new bus to accommodate the existing and future neutral conductors. Safety is paramount when working with electrical systems. Before starting any work, always disconnect the main power supply to the distribution panel. This will prevent the risk of electric shock and ensure a safe working environment. Use appropriate lockout or tag-out procedures to prevent accidental re-energization of the circuit. Once the power is safely disconnected, remove the cover of the main distribution panel. Carefully inspect the interior of the panel to identify a suitable location for mounting the new neutral bus. Look for an area with enough physical space to accommodate the bus and its associated conductors. The location should also allow for easy access and future maintenance. Most neutral buses come with mounting hardware, such as screws or brackets. Use these to securely attach the new bus to the identified mounting location within the panel. Ensure that the bus is firmly affixed and cannot move or vibrate. Torque the connections according to the manufacturer's specifications to ensure a reliable and safe installation. After installing the new neutral bus, connect the neutral conductors from the sub-panel and any other circuits that require a neutral connection to the new bus. Use appropriate wire connectors, such as wire nuts or terminal blocks, to create secure and reliable connections. Ensure that all connections are tight and properly insulated. Proper bonding is essential for maintaining the integrity of the grounding system. Make sure that the new neutral bus is properly bonded to the grounding system of the panel. This may involve connecting a grounding conductor from the new bus to the main grounding electrode conductor or the panel's grounding bus. Refer to local electrical codes and regulations for specific bonding requirements. When adding a neutral bus, ensure that there is adequate space in the panel to accommodate the additional conductors and bus. Overcrowding the panel can lead to overheating, insulation damage, and other safety hazards. If necessary, consider using wire management techniques, such as bundling or routing conductors to maximize space utilization. Once all connections are made and the new neutral bus is securely installed, reinstall the cover of the main distribution panel. Ensure that the cover is properly aligned and securely fastened. Before restoring power, double-check all connections and components to ensure that everything is in its proper place and functioning correctly. After verifying the installation, carefully turn on the main power supply to the distribution panel. Monitor the system for any signs of malfunction, such as unusual noises, smells, or tripped breakers. If any issues arise, immediately disconnect the power and investigate the cause. If you are not comfortable performing electrical work or if you lack the necessary expertise, it is always recommended to hire a qualified electrician to install the new neutral bus. Electricians have the training, experience, and tools to perform the job safely and in compliance with local electrical codes. Keep in mind local electrical codes and regulations. Always adhere to local electrical codes and regulations when installing a new neutral bus or performing any other electrical work. These codes are designed to ensure the safety and reliability of electrical systems and to protect people and property from electrical hazards. Neutral buses play a vital role in electrical distribution systems by providing a common point for neutral conductors to connect and return current to the source. They help to maintain a balanced electrical system, reduce voltage drops, and prevent electrical noise and interference. Adding a neutral bus can improve the overall performance and reliability of the electrical system. When selecting a neutral bus, consider the amperage rating. Ensure that the new neutral bus has an amperage rating that is sufficient to handle the anticipated load. The amperage rating should be equal to or greater than the sum of the amperage ratings of all the circuits connected to the bus. Use appropriate wire sizes. When connecting conductors to the new neutral bus, use wire sizes that are appropriate for the amperage rating of the circuits. Refer to the National Electrical Code, NEC, or local electrical codes for guidance on wire sizing. Using undersized wires can lead to overheating and potential fire hazards. Maintain proper grounding. Proper grounding is essential for electrical safety. Ensure that the new neutral bus is properly grounded to the grounding electrode system. This will help to protect against electric shock and prevent equipment damage. When working with electrical panels, always use appropriate personal protective equipment (PPE), such as safety glasses, gloves, and insulated tools. This will help to protect against electrical hazards and prevent injuries. Regularly inspect the electrical panel and neutral bus for any signs of damage or deterioration. Look for loose connections, corroded terminals, or damaged insulation. Repair or replace any damaged components as needed. Keep the electrical panel clean and free of debris. Dust, dirt, and other contaminants can accumulate in the panel and cause overheating or other problems. Regularly clean the panel with a vacuum cleaner or compressed air. If you are unsure about any aspect of installing a new neutral bus, consult with a qualified electrician or electrical inspector. They can provide guidance and ensure that the installation is done safely and in compliance with local codes. Adding a neutral bus to a main distribution panel can be a complex and potentially hazardous task. It is important to take all necessary precautions and follow proper procedures to ensure a safe and reliable installation. By understanding the function of a neutral bus, following the steps outlined above, and consulting with qualified professionals when needed, you can successfully add a neutral bus to your main distribution panel and improve the performance and safety of your electrical system. Always remember that electricity can be dangerous, and it is essential to prioritize safety when working with electrical systems. Take your time, follow instructions carefully, and never hesitate to seek professional assistance if you are unsure about any aspect of the work. By doing so, you can protect yourself, your property, and others from electrical hazards. A qualified electrician can assess the situation, determine the appropriate solutions, and perform the work safely and in compliance with all applicable codes and regulations. Improper electrical work can lead to serious consequences, including electric shock, fire, and equipment damage. It is always best to err on the side of caution and seek professional assistance when dealing with electrical systems. In addition to the safety aspects, there are also performance considerations when adding a neutral bus. A properly installed neutral bus can improve the overall performance and reliability of the electrical system. By providing a dedicated point for neutral connections, it can reduce voltage drops, minimize electrical noise, and prevent interference with sensitive electronic equipment. These improvements can lead to more efficient and reliable operation of electrical devices and appliances. When planning to add a neutral bus, consider the future needs of the electrical system. Anticipate any future expansion or additional circuits that may be required. Choose a neutral bus with sufficient capacity to accommodate these future needs. This will avoid the need for further modifications or upgrades in the near future. Adding a neutral bus is not always a straightforward process. There may be unforeseen challenges or complications that arise during the installation. It is important to be prepared for these possibilities and to have a plan for addressing them. This may involve consulting with an electrician, obtaining additional materials, or modifying the installation plan. By being flexible and adaptable, you can overcome these challenges and ensure a successful installation. Finally, remember that electrical codes and regulations are constantly evolving. It is important to stay up to date with the latest changes and to ensure that all electrical work is performed in compliance with these codes. This will help to ensure the safety and reliability of the electrical system and to prevent any potential legal or financial liabilities. In summary, adding a neutral bus to a main distribution panel requires careful planning, attention to detail, and adherence to safety guidelines. By following the steps outlined above, consulting with qualified professionals when needed, and staying up to date with electrical codes and regulations, you can successfully add a neutral bus and improve the performance and safety of your electrical system. Adding a neutral bus to an electrical panel requires understanding several important concepts. Firstly, the purpose of a neutral bus is to provide a central connection point for all the neutral wires in an electrical system. Secondly, this ensures that the current returns to the source safely and efficiently. Thirdly, the National Electrical Code (NEC) provides guidelines on how to properly install and maintain electrical systems, including neutral buses. Fourthly, proper grounding is crucial for electrical safety. The grounding system provides a path for fault current to return to the source, tripping the circuit breaker and preventing electrical shock. Fifthly, when adding a neutral bus, it is important to ensure that it is properly bonded to the grounding system. Sixthly, this means connecting the neutral bus to the ground bus or the metal enclosure of the electrical panel. Seventhly, the size of the neutral bus should be appropriate for the expected load. Eighthly, the NEC provides guidelines on how to calculate the load on a neutral conductor. Ninthly, it is important to use the correct size of wire for the neutral connections. Tenthly, the NEC provides tables that specify the ampacity of different wire sizes. Additionally, when working with electrical panels, it is important to follow all safety precautions. Always turn off the power to the panel before working on it. Use insulated tools and wear appropriate personal protective equipment, PPE, such as safety glasses and gloves. If you are not comfortable working with electricity, hire a qualified electrician to do the work. Proper installation of a neutral bus is essential for the safe and efficient operation of an electrical system. By following the NEC guidelines and taking appropriate safety precautions, you can ensure that the neutral bus is installed correctly. The NEC is a comprehensive set of standards that covers all aspects of electrical installations. It is important to consult the NEC when adding a neutral bus to an electrical panel. The NEC provides detailed information on the requirements for neutral conductors, grounding, and bonding. It also provides guidance on how to select the appropriate size of neutral bus and wire for the expected load. The NEC is updated every 3 years, so it is important to use the latest version. The NEC is available from the National Fire Protection Association, NFPA. In addition to the NEC, there may be local electrical codes that apply to electrical installations in your area. It is important to check with your local building department to determine what codes are in effect. Local electrical codes may be more stringent than the NEC. When adding a neutral bus to an electrical panel, it is important to follow all applicable codes and regulations. This will help to ensure that the electrical system is safe and reliable. Understanding voltage drop is very important. Voltage drop is the decrease in voltage that occurs along a conductor due to its impedance. Excessive voltage drop can cause electrical equipment to malfunction. The NEC provides guidelines on how to calculate voltage drop. When adding a neutral bus, it is important to consider the potential for voltage drop. The length of the neutral conductors should be kept as short as possible. The size of the neutral conductors should be large enough to minimize voltage drop. Additionally, surge protection is a critical aspect of electrical systems. Surge protection devices, SPDs, protect electrical equipment from voltage surges caused by lightning or other events. SPD should be installed at the main electrical panel and at any subpanels. When adding a neutral bus, it is important to ensure that the SPD is properly connected to the neutral bus. A ground fault circuit interrupter, GFCI, is a safety device that protects people from electrical shock. GFCI should be installed in areas where there is a risk of exposure to moisture, such as bathrooms, kitchens, and outdoor areas. When adding a neutral bus, it is important to ensure that all GFCI circuits are properly connected to the neutral bus. An arc fault circuit interrupter, UFSI, is a safety device that protects against fires caused by arcing faults. UFSI should be installed on all branch circuits that serve dwelling units. When adding a neutral bus, it is important to ensure that all UFSI circuits are properly connected to the neutral bus. Electrical safety is paramount. Working with electricity can be dangerous. It is important to follow all safety precautions when working with electrical panels. Firstly, always turn off the power to the panel before working on it. Secondly, use insulated tools and wear appropriate PPE such as safety glasses and gloves. Thirdly, never work on electrical panels in wet or damp conditions. Fourthly, if you are not comfortable working with electricity, hire a qualified electrician to do the work. Fifthly, proper installation of a neutral bus is essential for the safe and efficient operation of an electrical system. Firstly, it is recommended to consult with a qualified electrician. Secondly, ensure compliance with all local and national electrical codes. Thirdly, verify the compatibility of the neutral bus with the existing panel. Fourthly, use appropriately sized conductors for all connections. Fifthly, double-check all connections for tightness and proper insulation. Sixthly, label all new connections clearly. Seventhly, test the installation after completion. Eighthly, maintain records of all work performed. Ninthly, schedule regular inspections of the electrical system. Tenthly, prioritize safety in all electrical work. Finally, if you're adding a subpanel, ensure the neutral and ground are isolated in the subpanel itself. The subpanel should have separate neutral and ground buses. The neutral bus in the subpanel should be connected only to the neutral conductors of the circuit served by the subpanel. The ground bus in the subpanel should be connected to the grounding electrode conductor, which runs back to the main panel. This ensures that the neutral and ground paths are kept separate, which is important for safety.